Today in the Spare Tech Room, I'm going to tell you how you can get yourself a little external portable hard drive that's up to 10 times as fast as some of the other hard drives, all without spending an arm and a leg. Let's get into it. What's up, my dude? Your friendly neighborhood Tony here, and welcome to the Spare Tech Room, where I try to channel the power of hyperfixation to hopefully help you make better tech choices. Now, at this point, I think we're all pretty familiar with the concept of a hard drive, and if you're a computer nerd like myself, you might even know the different types of hard drives, whether that's going all the way back to some of the spinning hard drives that we've been using since way back in the day, or more recently with some of the smaller SSDs, or even some of the NVMe drives that you have inside your computer. There's all different kinds at all different prices at all different speeds. And which one you end up buying is going to be completely dependent upon your individual needs. But if you want ultimate speed and ultimate portability, I think I got something for you. What we're going to take a look at today is an NVMe SSD Enclosure. Let me explain to you why I think this might be something worth looking into. So generally, when it comes to hard drives, especially external portable hard drives, the big factors that you're going to be looking for are size of the drive and speed of the drive. Now, if you don't care about speed, you can go with something like this old spinning drive by Seagate. This one's 4 terabytes. I've got one that's even up to 22 terabytes, and those aren't going to cost you an arm and a leg, but they are going to be very, very slow. In fact, I'll show you how slow later on in the video when I run full tests on all the drives I have. But if you just want a big old hard drive and you don't really care how fast it is, this is totally fine. Now, if you want something that's a bit faster, but a bit more expensive, then you're going to be looking at a smaller SSD like the one we have here. This one's the Samsung T7. It's a really popular drive. And if you're looking at not really moving around a ton of files, then this might be the perfect drive for you. But if you're somebody like me who does a lot of video editing and also a lot of game emulation, I want to have a very large drive with a very fast speed. And not only that, I want a drive that's going to last me. You see, a lot of these external SSDs are not meant to be written to and used over and over again, day in and day out. But a drive that is meant to be used day in and day out is an NVMe drive. Normally, these are the ones that are going to be inside of your computer. And because of that, you'll oftentimes have your operating system or important files on that you're accessing regularly. So with this, we're taking one of those NVMe drives and putting it inside of a Thunderbolt enclosure, which will allow you to get a ridiculous amount of speed, more than any of the other drives I have here, and also allow you to get something that has a lot of space on it. The one I have in here is a 4 terabyte drive. And of course, because it's an NVMe drive and because it's meant to be inside of your computer running every single day, all day, it's gonna last you a very long time. So before I show you all the test results that I got with this drive and with this enclosure, let's go ahead and jump back in time. I'm gonna show you how I set this whole thing up. Then we'll jump forward in time, but still back in time from this point, so I can show you how to set this up on your computer. And then finally, we'll jump forward in time even further so that I can show you the test results of all the different drives. This is like a Christopher Nolan movie or something. Anyway, okay. Back in time. Here we go. Thanks, future me. Nice haircut. Did you get a haircut? All right, here we go. These are the items that we are going to be using to set up our new hard drive. Now, a couple of things. One, I want to talk about the actual NVMe hard drive that we're going to use, but we'll get to that in just a second, because I do have to say that the enclosure itself was provided to me by Yottamaster. Of course, they have no say over what I say in this video, and they're not seeing this video before it goes live. So my thoughts here are my own, and whatever I end up thinking about this is going to be 100% unfiltered, my personal opinion. So we'll talk about that enclosure a little bit more in just a moment. I do want to mention the NVMe drive that we have here, and there are a ton of different options when it comes to NVMEs. I'm not going to give you the full spiel over what all the differences are. I will say that there are different generations. This is a Gen 4 NVMe drive. There is also Gen 3 and Gen 5. And the differences between the 3 generations are going to be mainly the speed. Now, right now, Gen 5 can be pretty pricey and it's not compatible with everything. So Gen 4 is kind of like the sweet spot. And with that, there are a ton of different companies that make NVMe drives. Some of them you'll probably have heard of, whether it's Western Digital or Samsung. And then you have other companies like this one here, Team Group, which if you're not already in kind of the PC building space, you might not have heard of them, but they are a very good, reputable company. And this particular drive that I went with here was basically the best bang for buck drive that I could find. Now you'll also notice this is a 4 terabyte drive. I wanted to get the biggest drive that I could get that still didn't cost me an arm and a leg. And again, this was basically it. I'll link to this drive in the description box below, but from all the research I've done, this is the one to get. It comes in 2 terabytes as well as 1 terabyte. So if you don't want something quite as large as this, you can save some money and go with the smaller drives. But for me, in this particular situation, I'm just trying to get the most that I can possibly get for the most reasonable price. And so that's why I went with this. So we'll crack that open in just a minute. Let's go ahead and open up this M.2 SSD enclosure. Now, this thing is rated at 40 gigabits per second. Of course, the drive itself is not going to be hitting 40 gigabits per second, but we'll do some testing to see what kind of speed we can get out of a Gen 4 NVMe SSD. And I'll compare that to more typical spinning drives and even some other SSD drives, so that way you can get an idea of what kind of speed we're looking at here. But for now, we'll just take a quick look around this box. One of the things that I'm really excited about here is that the Yottamaster drive has a built-in fan in the actual enclosure. So it should be able to keep the hard drive itself cool under load. So if I am moving very, very large files around, or if you're using this to hold your video games or other things that you're accessing regularly, the drive generally will heat up, and this should keep it cool. So let's go ahead and open this up here. I've already cut the tape at the top, so we'll just pop open this and take a look inside. So this slides right out, and it looks like we've got a few different things in here. A little instruction booklet, which appears to be in Chinese and I believe in English. Yes, there's some English in here as well. So we'll take a look at that in just a moment to see how we set this up. We also have a USB-C to USB-A cable here, which I think also has USB-C on both ends. So yeah, we have USB-C on one end, and on this end we have USB-A, and this, yep, pops right open to give us another USB-C. So this should be a Thunderbolt rated cable. Solid here. It's actually pretty good quality as far as I can tell. We also have, what's in here? A little M.2 clip to kind of pin down the M.2 drive once we get that installed. And then the actual enclosure itself. Oh, wait, there's something else in here as well. Oh, it looks like, is this some sort of a heat sink maybe? Something to put on there? We'll take a look at that. And oh, a little thermal pad as well. So that's going to be really important. You're going to want a thermal pad if you're going, especially with a Gen 4 NVMe SSD. So we've got that as well. Lots to set up here. But let's take a look at this enclosure. It's a little bit beefier than I thought it would be, but I kind of like that. It's made out of, I can't tell if that is, what kind of metal that is, but that is pretty heavy duty. Let's peel off this plastic here. Love doing that. And yeah, it's got a pretty durable structure here. It feels like something that's going to be safe to kind of toss around, although this might get scratched up a little bit. I'm not entirely sure. But overall, the quality, as far as I can tell, just first impressions, is really good. There's your USB-C port there, and then you've got some ventilation built in on both sides here, so it should also help with cooling. Now, as far as the instructions are concerned, this should slide right open. Let's see here. Oh, there we go. That slides off. You can pop the lid off of this thing, and here we have the actual board itself. That's where you're going to insert the NVMe drive. Here's the little fan to keep it cool. Now, this will fit NVMe drives of various lengths. The one we have here is kind of your typical sized NVMe, but if you have one of the shorter drives, those will also fit in here. So it should work with pretty much any setup. Of course, these standard length NVMe drives are usually going to be better as far as price is concerned, price to size and performance. So let's go ahead and open this as well, and that way we can get this thing all set up. So we'll go ahead and slide that open, pull out the SSD itself. Now this you can get with a heatsink or without. I went without because we already kind of have that set up. But if you needed to get it with an actual heatsink, you could do that as well. But it's unnecessary in this particular case. All right, we pop that open and we have access to our NVMe drive. There we go. Move that to the side here. We don't need that. And here it is, 4 terabytes. And I believe the rated speed here is something like 7,000 megabits per second, which is really solid. Now, before we insert this into the actual enclosure itself, we want to go ahead and apply the heat shield and all of that. So we'll grab that real quick. I'm just going to set that down. And here we have this kind of silicone substance that's going to help dissipate heat. We'll want to peel off the plastic from it. So I'll go ahead and do that. We'll just start with one side here so we can stick that to the NVMe drive. And from here, we'll want to just slap it on here, kind of moving it towards the front a bit because we want to leave this back part open to clip down into the enclosure itself. So we want to make sure that we leave some space for that. And so I'm just going to grab this try to do this first time, see if I can get it right. And with the power of editing, you think I did that on my first try, and that's all that matters. So, okay, we've got that. Now let's peel off the other side of it. There's a plastic on that as well. So we want to get that off. We don't want that to be stuck on there. Set that to the side for now. From here, we'll want to attach this little heat sink that came with it. That should clip on, I believe. There we go. It just kind of sits over top of it. It doesn't clamp down or anything like that, so don't try to press it too much to make it click or anything like that. It just kind of sits over the top and gets stuck to the kind of adhesive strip that we put on there. And so now we should be able to slide this right in. Now, these NVMe drives, if you don't know, they are keyed, so you'll notice there's a notch on one side but not on the other. So you want to make sure you line that notch up with the notch in here on the enclosure itself. And we're just going to slide that right into place. There we go. And then we should be able to press that down and attach the clamp itself. So let me grab that real quick. Again, that was in this little baggie over here. So we're gonna go ahead and slide that into the notch on the actual NVMe drive. So it's stuck there, and then we'll drop it into the enclosure just like that. And then we just turn to lock it into place. Okay, quick cut. As you can probably tell here, we've run into a bit of a snag and I've had to disassemble the enclosure itself, and I'm going to explain to you exactly what's going on here, and then I will tell you what I'm going to do, and then future me will follow up to let you know exactly how it all went. So first things first, in order to insert the M.2 into the enclosure itself, as you can tell, I've removed this from the case from the enclosure. You insert it into here, as we mentioned, making sure that the key lines up, and then here, I'll just do that real quick so you can see what we're working with. Once we have that in there, you would then pin down this side to the board itself. Now, most M.2 cases, enclosures, will have some sort of screw that you then screw into place here. But this, instead, has a plastic clip. Now, this plastic clip is broken. And the reason why it's broken is because the way it works. So you're supposed to be able to insert one side here into this, and it will go through the board itself, and then you turn it to lock it into place. The problem is that I'm running into here is that the clip itself does not have enough space to go through the entire board. And in fact, even when I remove the M.2 drive itself and insert the side of this that should go through the board, it will go through, but then when you attempt to turn it to lock it into place, it simply won't. And I don't know if you can see that. It's going to be hard to tell, but the board itself is thicker than the gap on the plastic piece. So you simply cannot lock it into place. That is an issue. So what I'm going to do is I'm going to reach out to the manufacturer and see what they have to say about that. See if there is a replacement part that can be sent. But again, this is a review of this product. And if this is an issue that I'm running into, undoubtedly, this will be an issue that perhaps other people will run into. And we want to make sure that I express exactly how this is going for me. So what I'm going to do in the meantime, just so that I can kind of complete this process and get some testing done, is I am going to insert this in the M.2 slot on the board, and we're going to put this back in place. Now, of course, this won't be pinned down, so it's not going to be the most secure. So I definitely wouldn't recommend throwing this into a bag or anything like that. But just so that I have time to actually test the speeds on this drive, I'm going to do that. And like I said, I'll be reaching out to the manufacturer, and I will add a note here, or at least future me will, in order to let you know exactly how this went. But something to consider if you're trying to pick up one of these M.2 enclosures is you want to make sure that you're looking at reviews to see how do the parts themselves hold up. Are there any kind of issues that you might run into? But we'll go ahead and get this set up. I'll screw the board back into the enclosure itself, and we'll get some testing going. So let's go ahead and do that now. Okay, so I hope that was helpful. Now, of course, we did run into a little bit of a snag putting this thing together. I just reached out to the manufacturer, so I'll be sure to throw in a note as I'm editing this video to let you know how that went. Of course, if you do pick up this enclosure on Amazon, you do have the Amazon return window. So if you have any issues piecing it together like I did, you can always return it or swap it out for a different drive, or rather a different enclosure. So something to keep in mind there. If you do want to check this out on Amazon, I'm going to go ahead and drop a link in the description box below. I just took a look before I started recording this video and it was on sale for quite a bit off. So if you want to check that out, I'll link it in the description. Go ahead and take a look and see what you think. Hey, what's up? This is Tony from the far-flung future. In fact, I'm actually recording the video that you're watching right now. I wanted to follow up on the whole issue that I had with putting this thing together. I reached out to the company and they responded almost immediately and sent out a complete replacement unit for me. So kudos to them for excellent customer service. If you're having any issues at all, if you, of course, order this through Amazon, you have the Amazon return policy. So I would highly recommend taking advantage of that if you have the opportunity. Again, I'll link to the Amazon link for this enclosure in the description box below. But yeah, they sent out a new unit to me. I was able to put in the new clip. It worked perfectly fine, not an issue. And I've been using this for about a week now, and it is insane how fast this thing is. I want to be very clear about this. I'm moving around files that are, you know, dozens of gigs in size, and they move over to this hard drive back and forth from my computer in a couple seconds. It's insane. So yeah, I am totally in love with this thing. I'm going to be using this every day for the foreseeable future. But okay, back to, I think, past me to tell you more about the setup. So what we're going to do now is we're going to jump on over to my computer. I'm going to show you exactly how I got this thing set up, because it is a little tricky. It's not as easy as just plug and play. There are a couple of hoops that you have to jump through in order to get this to work, and also to get it work at its optimum speed. So let's jump to the computer now. I'll show you how to set it up, and then we'll run a few tests so you can see how fast this thing is. Okay, so here we are on my home screen here. Now, when you first insert the drive itself into your computer, of course, you're going to want to use the Thunderbolt cable that came along with it. But when you do, it may not be recognized on your computer. And the first thing you're going to want to do in order to get this to show up, and I'll do this right now with you, even though I've already set it up, so it'll be a little bit different for me, but I'm going to plug in the drive, and we've got that plugged in to a Thunderbolt 4 connection. Now for me, it popped right up because I've already initialized the drive. So what you'll want to do instead is go ahead and just go to search and type in disk partition, and you're going to want to create a partition for that drive. Now it's going to search your system here, and you'll notice I have a few drives already in place. If yours is not, you'll scroll through here and you'll see one that has unallocated space, and you'll essentially just right click on that and create a simple volume. Now that's not showing up for me here because I've already done that on all these drives that I have on this particular computer. But if you don't, you'll just follow those prompts, and then once you've gone through and created that drive, created that partition, it will pop up for you and show on your screen. Now, one other thing that you're going to want to make sure you do, because even once you get the drive loaded and in place, it's not going to be as fast as it should be, because the system is essentially setting it up as if it was just regular old external hard drive that you're going to be unplugging and moving around, but you want it to work at its optimum speed. So what you're going to want to do here is go to your computer where the drive is located. You're going to right click on the drive, go to properties. Then, and I'll move this so you can see it a little bit easier, you're going to go into hardware. You're going to find the drive that you're looking for. For me, it's the team drive here. You're going to select properties on that, then click change settings. And again, we'll move this over here. You'll go to the policies tab, and then you'll want to select better performance. By default, it'll be on quick removal. Now, the differences between these two, as simple as I can put it, quick removal, as I mentioned before, is basically like a drive that you're going to be plugging in and unplugging willy-nilly without any concern. Better performance will give you way better write speeds, but because of that, you will have to make sure that when you're removing it, that you're not immediately moving any data, because it does have to write the cache in Windows before you actually disconnect the drive. So you'll want to select better performance, you'll want to select enable write caching on the device, and you'll want to leave this other part here unchecked. And then once you do that, you click OK, you close this down, and that drive will work so much faster than it would otherwise. That is essentially how you get it set up. From there, you should be good to go on pretty much any computer with the drive. Let's go ahead and run some tests so you can see just how fast this thing is compared to some of these other drives I have. So what I've got here is the Blackmagic Disk Speed Test. This is a free program that you can download, and we are going to try this on various different drives. The first one I'm going to disconnect the new drive that I have set up here. And we're going to go ahead and hook up my old Seagate drive, the 4 terabyte drive that I showed you earlier, just so that way you can get kind of a baseline to see how fast this type of drive will be. Now, again, if you are just looking to store a bunch of data and you don't need to access it quickly, you can get some pretty large hard drives, mechanical hard drives, for pretty cheap. So we're going to hook this up right here through my USB 3 connection, and that's going to pop up on the screen here any moment. Okay, there we go. It's the Seagate F drive right there, and we'll start our test. And this is going to show you again a baseline of how fast these old mechanical drives are. So from here, we are getting a solid 39 megabits per second write, and it looks like we're getting just over 40 megabits per second read on this drive. Now, again, this drive is going to be totally fine for long-term storage. As you can see, I have another 20 terabyte drive on this particular computer. That's what I use for my Plex server, so I just drop tons of movies on there, and I barely have a couple terabytes used up at this point. But if you're looking for just long-term storage, something like one of these old school cheap drives would work just fine. But again, you're getting 39 megabits write, 41 read, and let's see what happens if we then step it up a notch and go to the Samsung T7 drive that I showed you earlier. Okay, so we've got that T7 drive hooked up here. Now this is an SSD drive, and I am using, for each of these, the cables that came with the drives themselves. So I do have separate Thunderbolt 4 cables that I could be using here, but I want to make sure I'm giving you exactly what you would get if you bought any one of these drives yourself directly. So let's go ahead and switch over to another target drive here. Now again, let's remember this first drive was around 40 megabits per second. If we switch over to the T7 itself and go ahead and start a test on that, okay, we are getting much faster speeds here. We're looking at 172 megabits per second, right? And whoa, crazy fast reads, 847. Let's see what happens if we continue to run this a few more times. 340 megabits, right? 847 read. So we're getting some pretty decent read and write speeds here. 400 write, 840-ish read again. So it looks like the read is going to settle at around 840, the write somewhere in the 400s. That's a huge jump from that original hard drive that we tried out. So this, again, could be really great. You'll notice here that Blackmagic tells you what kind of footage that you could work off of this drive with. So you could edit up to, 4K 60 footage right off of this drive without an issue. It's only once you get into some of those higher resolutions, into like 8K and things like that, that it's really just still not going to work for you. But 400 and some odd megabits write, 800 some odd read, that is very respectable. So let's go ahead and swap this out now so I can show you the difference between even this, what I would consider pretty fast drive, compared to the NVMe enclosure that we just set up. Okay, so it just popped up for me here, the F drive on here. So I'm gonna go ahead and select that target drive, and we are going to start this test here. Now again, we got somewhere around 40 megabits read and write for the standard mechanical drive that we had used before. We got somewhere in the neighborhood of 400 megabits write, 800 some odd read for that pretty high speed SSD that we just had connected. Let's see what we do with this bad boy. Holy cow. 2,700 write, 2,700 read. This is absolutely insane, the level of speed. And you'll notice down here, this can edit whatever you want it to edit, up to 12K, which I don't even know any kind of camera that can film in 12K. But this drive is absolutely insanely fast. 25 to 2,700 write, 2,700 read. I can't imagine anything that you would need to be faster than this, or any reason you would need this to be faster than what it is. Now, again, this is connected using the cable that came with the device. It's a Thunderbolt 4 cable. I do have another Thunderbolt cable here. Let's try that out real quick to see if it makes any difference. I don't know if it will. I don't think it will, but you never know. Let's see how the cable is that came with the Yottamaster enclosure. Now, the cable I just connected is an Anchor Thunderbolt 4 cable, so it is a very good quality cable. Let's see how that does, if it makes any difference whatsoever. Okay, looks like we're still getting 2,700 megabits write, 2,800 read, so around the same neighborhood, the same ballpark, 2,800 read and write. So again, this drive is absolutely insane. Let's go ahead and jump back to the main camera here so I can finish this thing off for you. Okay, so overall, what do I think about the Yottamaster NVMe enclosure and really just Thunderbolt NVMe enclosures in general? Well, here's the thing. When it comes to technology, oftentimes there is a scale of price to performance, and there's a point where you reach at that scale that the level of performance upgrade that you get for the additional price just isn't quite worth it. You see it all the time, like for example, with graphics cards. You can get yourself a graphics card that is hundreds of dollars more expensive just to eke out a couple extra FPS. And in that particular case, I would say it's totally not worth the upgrade most of the time. Now, in this case, getting yourself something like an NVMe SSD enclosure, yes, it's gonna be a little bit more expensive than it would be to just get a regular SSD, but the upgrade in speed is absolutely insane. I'm not joking, I was stunned seeing how much faster this is than a typical SSD. So for me, as somebody who wants to use an external hard drive like this for editing videos or for emulation or for any other number of reasons that you would want to move around large files quickly, it is 100% worth it. This is a choice I will absolutely not regret. If you have any questions about the Yottamaster enclosure, NVMe drives in general, whatever, let me know in the comments below. I'd love to hear it and I'll do my best to help you out. Again, this channel is all about trying to help you make better tech choices, so I hope I did that here for you today. Go ahead and check the links in the description for both the NVMe enclosure case and the actual drive that I picked up. Otherwise, I'll catch you next time in the spare tech room. Be good.